Okay, so I'm Mrs. Bowman, and we are getting ready to start on our next round of school-wide learning. We've been focusing on the English part of the ACT, and now we're getting ready to focus on the best part, which is the math part. So for the next 6 weeks, we'll be talking about the 6 different subcategories of the ACT, the math ACT. We're going to be looking at pre-algebra, elementary algebra, intermediate algebra, and then we're going to get into coordinate geometry, and then plane geometry, and then trigonometry. So the purpose of this is hopefully that we can give you a little bit of a refresher of each of those 6 areas. And so then when you're looking at these problems through the week, then you'll have some idea of what these problems are about. So a couple of things about the math ACT. It is going to be 60 questions, and you have 60 minutes. So one of the toughest things about the math part is that you just don't have a lot of time. So you've really got to practice working on 1 minute per problem and feel what that time crunch is going to be like. So starting this week, we're going to look at pre-algebra. And some of the topics that you're going to see on pre-algebra will be things like multiples, prime numbers, and factors, divisibility and remainders, percentages, ratios, and proportions, mean, median, and mode, probability, absolute value, exponents and roots, series, and then some word problems. So the first thing we're going to look at would be multiples, primes, and factors. So I think we're probably pretty comfortable with multiples. Multiples are going to be things like, multiples of 5, 10, 15, 20. Now, a lot of times on the ACT, they're not just going to say, what are some multiples of 3? They might say, what are multiples of between 3 and 21, multiples of 3 between 3 and 21, and what's the average of them. So you'd have to find the multiples and then also know how to find the average. So the next thing would be prime numbers. Now remember, prime numbers are numbers that are only divisible by that number in itself. So some of our prime numbers, we start out with 2, 3, 5, 7, and it keeps going that way. So you want to be familiar with what are prime numbers. And then factors are just numbers that can divide into other numbers evenly. So like if we were talking about the number 12, we could say that the factors of 12 could be like 1 and 12, 2 and 6, and then 3 and 4. So those would be factors. The next thing we want to look at, divisibility and remainders. So sometimes on the ACT, we have got a list of divisibility rules. Divisibility rules. You can look at, if you have a number like 2,000, obviously things like 9 and 7 might not go into it, but things like 5 and 10 definitely will. So think about some of those common divisibility rules that you've probably seen before. Honestly, on the ACT, they're probably going to say, hey, here's a number. Which numbers can divide evenly into it? So your calculator is going to be your best friend in that case, and just try dividing them. And then that leads us into a remainder. So the remainder is, if we try to divide it, it's the part that's left over. So think about in long division, when you did that back in elementary school, if you did long division, sometimes it's going to ask for what is that individual remainder, or sometimes it's just going to ask, does it have a remainder at all? All right. Next, we're going to look at percentages, ratios, and proportions. Now the biggest thing on percentages is that if you're given a percent, you have to remember that a percent is a part of 100. So remember back in elementary school when you would change your percents to a decimal, you've got to remember to move that decimal 2 places to the left, because you can't use like 25% and just multiply by 25. You'd want to take that and multiply by 0.25. Now ratios are just going to be comparing 2 numbers together. So ratios can be written, as a fraction, or they could be written as 2 numbers with a colon, or sometimes even just 2 numbers written with the word 2 in between them. So like on this example where we have 3 to 4, we've got 3 to 4, 3 over 4, and then literally 3 to 4. So ratios are often used in proportion. So that's really where we see ratios more often. So ratios lead us to proportions. That's where we take 2 ratios and we compare them with an equal sign. So proportions are what we love because we always want to cross multiply. On a proportion, you do. You set 2 fractions equal to each other, and then you just cross multiply and solve. The next one, mean, median, and mode. So you guys have seen mean, median, and mode probably since middle school. But a lot of times we're not just going to be given 5 numbers and we're going to be told to find the mean of a number. But what they're going to do is they're going to say, I have 3 numbers, and I want to add 1 more number to it, and here's what the mean is. And so you're going to have to find that missing number. Another part of mean, median, and mode, obviously, is going to be the median. So the median is when we take a set of data, and we line them up in order. So a lot of times they might give you a set of data in all different order, but we've got to line them up. And so the median is going to be that middle number. So you always remember median. The median's like the middle of the road, so it's going to be the middle of that set of data. Now, the mode is going to be the one that occurs the most often. It's okay to have more than one mode. So if you have the same number that shows up 3 times, or you have 2 different numbers that shows up 3 times, both of those could be your mode. All right, so probability. Probability, we have a couple different types of probability. Probability is helping us define what is the likelihood of something occurring. Now, kind of the most common types you're going to see are, what if I want to draw, what's the likelihood of drawing a red card out of a deck of cards? Or if I have 5 different color marbles in a bag, what's the likelihood of drawing out a green marble? So those are just going to be where you take the number that you want over the total number that you have. Now there's also something called the fundamental counting principle, and that's where you're figuring out how many possibilities would I have. For example, if you go into your closet and you realize you have 5 shirts and 10 pairs of pants and 7 pairs of shoes, and you want to know how many possible outfits do I have, you would just take those 3 numbers and multiply them together. So when you say you don't have anything to wear, you really have that many possible outfits to wear. Absolute value. So absolute value is going to be a number's distance from 0. So absolute value, one thing to remember is that it's always going to be positive once you've taken the absolute value because we're dealing with a distance. The negative is going to be the direction. So on the absolute value problems, a lot of times you're going to have to take the absolute value after you've done something to the number. So maybe you're going to subtract 3 minus 5, which would give you negative 2, but then when you take the absolute value of that, it's going to give you positive 2. So absolute value, remember, it's always going to be positive once you've taken the absolute value. All right, so for exponent rules, now there's several of these, and these would actually really be worthwhile making sure that you remember and you refresh some of these rules. So for example, it's something like x squared times x to the third. So in this case, since we have 2 bases that are the same, and we have our exponents up here, this is the same as writing x times x times x times x times x. So essentially we have x to the 5th power. So in this case, we could just do 2 plus 3, so we do get x to the 5th. So that's when we can add exponents. It's when we have the same base. Now, when we get to the next rule called the power rule, that's going to be like when we have x squared to the 5th power. This is saying that we have 5 groups of x squared. So in this case, we go ahead and we just multiply. So it's going to give us x to the 10th. Now, the next rule would be when we're dividing exponents. So if I have the same base and I have x to the 5th divided by x squared, on this problem, I'm essentially going to take 2 of these x's and cancel out with 2 of these x's here. So it allows me to just go ahead and subtract them. So here I would get x to the 3rd. What about when we have negative exponents? So if I had negative, or x to the negative 6th, that tells me that I need to change its location in the fraction. So in this case, it's going to move to the denominator of my fraction. So I essentially put this a 1 over x to the 6th. So this is going to become 1 over x to the 6th. And then the last exponent rule we want to look at is anything to the 0 power is going to be 1. So x to the 0 is 1. So I might have 5x squared y to the 3rd. All of this raised to the 0 is going to be 1. But where you have to be careful of is if the 0 is somewhere in our problem, the only thing that's going to be 1 here is x to the 0. So for the answer for this problem would be 5y to the 3rd. All right, so hopefully that helped you guys with the refresher on exponent rules. Again, if you can just remember when to add your exponents, when to multiply, and when to subtract, that's going to help you out a whole lot. The last thing that we have to look at is square roots. So you might see some cubed roots, but honestly, the most part you're going to see square roots. So you need to know how to take the square root on your calculator, and maybe even I've seen problems like the square root of 11. Which integer is that closest to? So some of the problems you're going to have to take the square root and then do something with it. But sometimes you just have to take the square root to compare numbers. So be familiar with some of your perfect squares and then also be able to take the square root on your calculator. All right, so that pretty much wraps up some pre-algebra part of the ACT. Hopefully you guys do well with these questions that I've given you. My idea for the way that this math school-wide learning should go is that Mondays, if you'll watch this instructional video, so each week we'll have one of these to go with it, and then kind of talk about the PowerPoint, talk about any questions. On Tuesday, you're actually going to get a copy of about 10 to, say, 15 questions based on these types of concepts. And the first day, all you're going to do is figure out what type of problem is this? What type of skill do I need to use? Is this an exponent problem? Is this a proportion problem? What type of problem is it? Then on Wednesday, if you'll give the students 1 minute per problem to actually solve the problems. So try to solve them, do your absolute best on it, and then just 1 minute per problem. Then on Thursday, ideally the students will get in small groups and compare their answers with each other. Just let them compare, see what their solutions are, see if they got the same answers, see if they can help each other out and coming to some kind of conclusion on what the answer should be. And then finally on Friday, I've got some solutions that you guys can look at, worked out, and you guys can actually go over what the correct answers are, and hopefully you also got the same correct answers.